Hey, welcome back. We're going to continue our discussion for line integrals, and for number 4 we have a very interesting problem. We want to evaluate the following line integral, x, y, z, ds, given c is this path right here. So this is our path right here, r of t, that's our path. Now if we recognize this, we should kind of recognize this equation. This is our helix from earlier this year. This is our path. And so remember, our helix kind of looks, it's our spiral right there. And it has a domain, for the most part, between 0 and 2 pi. Now, what is this question kind of looking at right here? So we have the c, remember the c right here. This c is talking about the line integral of the path. So we're trying to integrate the path, along the path. So we are trying to integrate a line on a path. So the line integral, right? So we're going to try to integrate this line right here. And this is that spiral. The xyz, remember, this is our density problem. And of course we have our arc length right here. That's that little ds right there. So what is this question basically asking for us right now? Well, I am going to integrate this path, this line in 3 space. I am going to multiply that little arc length times its density. So what is that going to give us? That's right, it's going to give us the mass of the spiral. That's what we're looking at here, the mass of a spiral. This could be a wire as it's going on. It could be electrical flow, current through a wire in physics. So this has a lot of really good applications for us. Now, the good news is our path is already parametric. Yay, us. This is already parametric. We should be happy about that. So let's go and do this. So the only thing we really have to do right now is to convert rho. That's that x, y, z. And I can do that really easy because they're telling me what x, y, and z is. Here's x, here's y, there's z. And if I multiply them all together, we would get 3t cosine t sine t. And yeah, you can simplify all of these if you want. Now I know I'm going to need my derivatives. X prime is just negative sine of t. Y prime is just cosine of t, and then of course z prime is just going to be 3. So we actually did, we did all of this throughout the whole year. We're just kind of piecing it all together right now. So now I can write out my line integral. C f of x, y, z ds is going to equal. Now remember, it's my helix, so my helix we're just going to go from 0 to 2 pi. It's parametric already, 0 to 2 pi. And if I plug in my rho, that's going to give us 3t cosine t sine of t times the square root of sine squared of t plus cosine squared of t plus 9 dt. So there's my rule. That's my rule. We don't like ds. ds right now is rectangular. It's an x, y, and z's. Very messy to work with. So we converted it to parametric. And now we only have to do it with one variable versus multiple variables right there. So let's see here. We solve it. We get 0 to 2 pi. I can simplify. 3t cosine t sine t. And that just becomes the square root of 10 right here. Factoring some things out, we're going to get 3 root 10, 0 to 2 pi, and what we're left with is t cosine t sine t dt. Go ahead and integrate this one real quickly. Oh no, that's really hard to integrate. Man, it'd be nice if we didn't have the t, it would just be u substitution. But we do, so I'm going to use a rule right here. Cosine of t sine of t, that is just 1/2 of sine of 2t. There we go. That looks awful. So I can rewrite this as this. So we're going to get, that's going to give me 3/2 root 10, 0 to 2 pi, t times the sine of 2t dt. Remember, I took the 2t out, right? I took the 1/2 out. And now this I can integrate. So how do we integrate this one? We have to use integration by parts. Unfortunately, if this was t squared, we can use u substitution. So this has to be integration by parts. So let's review that. My u is going to be t. My dv would be the sine of 2t. Du would be just dt. V would be, if I integrate this, we would get negative 1/2 cosine 2t. My rule, I'm going to worry about this at the very end. It's going to be u and v, so negative 1/2 t cosine 2t minus the antiderivative of v du, so that becomes 1/2 cosine 2t dt. And this I can integrate, that's just use substitution. We get minus 1/2 t cosine 2t plus this becomes now 1/4 sine of 2t, and that we'd evaluate from 0 to 2 pi, and then you'd multiply all this answer by 3 over 2 root 10, and that is, let's see what we get here. So we get this 3/2 root 10 times, plug in the 2 pi, we get negative pi, cosine of 4 pi just becomes 1, plus sine of 2 pi is just 0, plug in the 0, that's just minus 0 plus 0. Oh, this works out nice. So what do we wind up with? Negative 3 pi root 10 over 2. Probably made a mistake there somewhere. I'm sure I'll hear about it in my comments. Anyways, you guys enjoy, have some fun, and I will